Alright, today's video is going to be on our introduction to solving quadratic equations. That's going to be our next unit. And there's going to be 4 methods we're going to use for solving quadratic equations. And there is a reason why we have 4 methods. It's not just to, show, look, hey, how much we know. We can show you how to do things 4 different ways. Each method is unique and it works better for certain equations than others. So we do have 4 different methods for that reason. And so it's not just overkill here. The first method that we're going to use to solve quadratics is called the square root method. It is the easiest method for solving quadratics, but it has limitations. So let's go ahead and look at what that's talking about. First thing we need to know is how we solve quadratic equations using the square root method is you're going to solve an equation traditionally. Just like you always have, you get rid of minus 5 by adding 5, just traditional solving. But instead of solving for x, you're going to be solving for x squared. And that's going to be the reason why we do that. And again, we're talking about quadratic equations. That's what an x squared refers to. The largest degree is 2. And so I solve for my x squared. And when I'm left with that, I can get rid of the square by taking the square root. Very similar to what we've done with things like Pythagorean's theorem and things like that. Now, some of you have got a background in this, others of you don't. We're in that area where some Algebra 2 classes got to do this, others didn't. And so some of you are going to find this a little bit easier than others, but for the most part, the square root method most people get pretty quickly. It is important to remember we're going to leave all of our answers in simplest radical form. We are not doing decimals. If you give me decimal answers on the test, I will take points off. We are leaving all of our answers in simplest radical form. Also, we will have imaginary answers. If you get the square root of a negative number, I expect you to be able to use an imaginary answer. A limitation upon the square root method is that it only works for quadratic equations that do not have an x term or a middle term. So when we look at something like this, we could solve this equation using the square root method. 3x squared minus 54 equals 31. There's no x term there. There's no middle term in my equation. If you think back to when we did all our factoring and things like that, we talked a lot about the middle term. There's no middle term here. We just have 3x squared minus 54. That allows us to use the square root method. It's the easiest method, but it is very limited. And we need to realize that an equation you can't solve using the square root method would be something like 4x squared plus 11x minus 7 equals 24. That does not work because it has that middle term, it has that x term in there. So we're going to look at a couple of quick examples here today, and we're going to start with a more complex one. I'm going to assume we can do the basics of solving here. I want to get some answers that'll require us to do a little extra work. So on this one, if I'm solving using the square root method, and I can do that because there's no x term in the problem, I solve just like I always have since I did in middle school. I minus 11, I divide by 3, which gives me x squared equals negative 24. The square root method tells us to solve for x squared first, get x squared by itself, then I'm going to take the square root on both sides. The one thing we have to be careful of when we're taking a square root to get rid of x squared, our answer is always going to contain a plus or minus. And the reason why it does that, if we think of a basic example, such as we'll do on the side here, if I would give you a simple problem like x squared equals 9, that's saying what number times itself is 9. And there's actually 2 answers to that, because 3 squared is 9, but negative 3 squared is also 9. That's why if we have x squared equals 9, we have to give 2 solutions, a positive solution and a negative solution. So we need to be aware of that. You will always get 2 solutions when we're solving these quadratic equations, and so therefore we need to make sure we're putting that plus or minus in when we're using the square root method. So I have 24. I'm going to use the factor tree to get myself down to a pair of 2's, a lonely 2 and a lonely 3. So that's going to be 2 radical 6. And it was a negative that I was taking a square root of, so I need to consider that to be an imaginary number because I took the square root of a negative. So my answer is going to be x equals plus or minus 2i radical 6. So we solve just like we've always done, except when you get x squared by itself, we take the square root of both sides. Then we get into all the things we did last chapter where we have to use simplifying radicals, imaginary numbers, and things of that nature. Our last example is going to be one where we have to deal with fractions in our answer. And as we look at this, you'll see the fractions are actually going to end up making this problem much, much easier, where I get 16x squared equals 81. And when I divide both sides by 16, 81 does not divide by 16, so I leave that in fraction form. And hopefully, you're starting to recognize numbers like 81 and 16 out there. And I take the square root of both sides. And so my answer is going to be x equals plus or minus. And when we talked about radicals last unit, we talked about how if you have a fraction inside a radical, that's the same thing as the square root of the top and the square root of the bottom. So the square root of 81 is 9. The square root of 16 is 4. So by leaving that in fraction form, I actually get a nice, neat answer. Now, if we wanted to, we could make some of these pretty ugly, and I might do that to you, where you would have to rationalize the bottom and do some of those things we did in our last chapter. So this is the square root method. Hopefully you shouldn't have any problems with this. If you have any issues, make sure you're asking those around you or write down any questions you might have, and we'll talk about them when I get back tomorrow.